All right, everybody, I'd like you to offer a warm welcome to Duncan Coutts. Duncan has been using...
Thank you.
Duncan has been using Haskell since the turn of the century, so he's a millenarian Haskeller, is one way to put it. He also founded a Haskell consultancy company 15 years ago, who you may have heard of. They've contributed quite a few speakers to our event today, that being well-typed. And he's been made major contributions to various aspects of the libraries and tools and all sorts of things. He's a pillar of our community. Thank you, Duncan.
Thanks very much. Hello. So David asked me to talk about the stuff around GHC, and not just to have it be all GHC the whole week. And I think there's sort of two reasons that David wanted me to talk about this. Or well, no, I think there's one primary reason, and then I have an ulterior motive for having said yes. So the primary thing is, if you are hacking on GHC and you need some cross-cutting feature and you think, oh God, this is going to have to be implemented in the tools somewhere, it's useful for you to know where to start. What would that mean? Which component would you be having to modify? Do you have to go and modify Cabal? Is that really hard, or is it not so hard? These sorts of things as a GHC hacker. And then my ulterior motive is to try and tempt you into not just hacking on GHC, but hack on some of the other unloved tools that are very important that live around GHC. So that's the goal. Need to have focus over there. I'm going to start by talking about some history, because actually these projects are quite old now. We'll see in a minute. The beginning is 20 years ago, so quite a lot has happened in that time, and I think it's really useful to understand some of the history, because it helps with understanding why are things the way they are. So we'll talk about that a bit. We'll look at an overview of lots of the components, how they relate to each other, and then we'll focus in on some of the components in particular. We won't really have time to go very deeply into any individual one, so I'm not going to be showing you that much code, or really any code at all, unless there are questions, in which case we'll just flip over and have a look at the code or whatever. So I've left time at the end for Q&A, but also please do just interrupt, ask questions as we go along. And either we'll do the run around the room with the mic thing, or we'll do the I repeat the question. We'll see what seems to work better for me. Okay. So why look at history? I think sometimes if you come along to a project and it is old, it's not always obvious what you can change and what you can't change. What is considered good and that shouldn't be changed, and this is an important design principle and don't change that, versus well, this is only here because of an accident of history, and really you ought to go and tidy that up. It's often very difficult to know the difference. So understanding a little bit of history, I think, can be really helpful. It can help to motivate why is the design the way that it is? What problem were people trying to solve at the time? Is that problem the same problem now, or is it different? Has the context changed now so that you should make a different decision now than the decision that people made 10, 15, 20 years ago? So I think that's useful. So in the beginning, there was GHC, but also there were several other compilers. RIP, hugs, NHC. But the story about libraries was not great. As I recall it, there were 3 libraries that were not distributed with GHC and that were big enough and important enough to have their own build systems and their own websites and their own tarballs being shipped around. I now can't remember what they all were. I think HackSML was one of them. I think GTK2HS was another, and I can't remember what the third one was. But that's the way I recall it, is that there were really very few libraries. In fact, I think there were more libraries that were bundled with GHC than there were that were shipped independently of GHC. And so because of that, there was a lot of pressure on Simon and Simon to accept lots more libraries, and pressure in the opposite direction, saying, no, thank you. We don't want to maintain your libraries for you. Thank you very much. Our release process is difficult enough as it is. without having more and more bundled together. So the people saw that it was not good. And so that's the problem, or that was the problem. And a project called the Haskell Library and Tool Infrastructure Project was established to try and solve this problem. So, okay, here's lots and lots and lots of dates. But the one at the very beginning is probably the most interesting one. That was when Isaac Jones, as he was then known, Isaac, what's his proper name now? Isaac, I can remember his.
I know how to spell it, but that's it.
Yeah, okay, yes, exactly. Spelling it, but I don't know how to pronounce it, I'm sorry. But at the time, he was called Isaac Jones. Proposed this library infrastructure project, which is what would subsequently become the Libraries and Tools Infrastructure Project, at the 2003 Haskell Implementers meeting. So yeah, we are just short of 20 years, if I can count correctly. So that's quite a long time, really. So he wrote he did a talk at the meeting and really just set out everything. I was looking the other day at his slides from that, and it pretty much sets out the entire vision. And there's a lot of stuff in there that's recognizable to what we have today. I was slightly surprised, actually. So then he started hacking on what became the Cabal library. And then there's other tools. The whole idea was that it wasn't just going to be Cabal, and indeed there would be a bunch of tools. Isaac's concept was of layered tools. So Cabal Get was something that David Himmelstrup started working on a couple of years later. I got involved at some point. I think because I was working on GTK 2HS at the time, and you kind of go down the rabbit hole of like, well, there's all these problems with trying to distribute things, and then this is why people end up with GHC. It's like going down and down and down and down until you get to something. Anyway, I stopped at packaging. Cabal Get got renamed to Cabal Install. That was the first version of Cabal Install. And we had some of the first hackathons as well. The first GHC hackathon was 2006. And the first Haskell hackathon was just a few months later. In fact, organized by me, long time ago. And it was much smaller. There's a photo from the Haskell hackathon in Oxford where we're just like, and there's like 15 of us or something. And how big is Zurihac these days?
We have 370 registrants, so about 400 people.
About 400, yeah. At some point, I complained to Isaac about the quality of Cabal's releases, and as punishment, he made me release manager. So my first release of Cabal was 2006, apparently. I had to check the logs. Anyway, I'm not going to go through anything beyond that, but the point is, there's a lot of history. The problems that Isaac and others originally identified, and again, this is like straight from his talk in 2003, was that it's difficult to distribute Haskell libraries. It was at the time. As I said, there were three where the projects were big enough that it was worth overcoming the friction. There was no standard build system. There were multiple compilers. Haskell language extensions were coming thick and fast, and they were different between different compilers. And libraries, of course, were also a moving target. There wasn't any way to express dependencies, and there was no central location to find code or distribute code. And it was a lot of manual work to build packages for Linux distributions. And Linux distributions at the time were kind of the premier way of getting your programs, your code, into the hands of other people. So Linux distros were even more important then than they are now, I think. And yeah, some of us in this room, have in the past worked on Linux distros as packaging Haskell for Linux distros. And from the early days, I'll remember that it was a lot of work, a lot of manual work to do these things. And so this is all hindering the ability to use Haskell at a large scale and develop on a large scale. So at the time, the sort of classic interface to build systems was, the GNU standard, or the classic Unix de facto standard of configure, make, and make install. And so that's what people were familiar with. That's what people expected. As I said, Linux distros were the state of the art in package distribution. They were taking all these difficult to manage, C libraries that you have to build using configure, make, and make install, and making them easy to install. And because there was that context of like Linux distros, there was already this idea of a distinction in roles between, the package author and someone who's a distribution maintainer, or someone who packages code for Linux distributions. Which, if you look at some of the other, these days, if you look at some of the modern, particularly language-specific package management tools, they don't always have this distinction of role. There isn't always this role for, a packaging person, and I think that was actually one of the interesting things that has led to some good design choices within Cabal and the whole system. Is this idea that you've got a package author, and there's a distinct role for the person who's building the code as opposed to the person who wrote the code. Yeah, it was at the beginning. It was quite unclear what the right way to do certain things was. In particular, there was rather a debate about, and sometimes rather heated debate, about should the package adapt to the environment in which it is run, which is the kind of the classic thing that if you were trying to install something on a Sun microsystem, you can't go and change the base system. It is what it is, and you just have to adapt to the fact that it's got broken libraries and other weird isms, and so that's what that's where the GNU configure style comes from. It just probes everything and then twists itself to fit within the strange, archaic, proprietary Unix that you happen to be trying to build the thing on. Whereas, as time moved on, like with Linux distros, the idea that the underlying system is a bit more flexible. You could adapt the system to fit the requirements of the package, like install some dependencies. Whereas on a classic Unix system, that might just not be an option at all. So, yeah, should the package adapt to the environment, or should the environment be made to adapt to the package, which really relies on package management, or some combination. Excuse me. So, but a package management style really relies on having lots of accurate metadata about dependencies. And this is actually where one of the the sort of problems for Linux distro maintainers came from, is that they were given loads of packages which are in this configure, make install style, and so the configure is this just big opaque blob of shellcode. But that's not what the package manager, the package management tool, RPM, deb, whatever, they need not just a configure script, they need metadata. They need to know what the dependencies are so they can go and figure out how to adjust the system to match. So there was a lot of effort that went into reverse engineering, extracting out metadata from packages. So and that was already sort of known at the time. So if you were starting a new system, you could start with something where the package author needs to supply accurate metadata, rather than this labor-intensive process of distro package managers, distro package maintainers, trying to figure out what the dependencies are. And as I say, it was actually a controversial question. I think, fortunately, it is no longer a controversial question. It's pretty much conclusively settled in the latter direction. But it's interesting that it wasn't clear at the time, and some of that is reflected in the Cabal architecture. Cabal is sort of a hybrid in some sense, which we'll see. So I think it will help to explain, I think, some of the design decisions that are still hanging around. So another aspect of this is like, who's in control? Who gets to make decisions? As I said, there's this distinction in roles between a package author and a user or a sysadmin or a whoever it is who's building the code, if we're building code to distribute, there is this distinction. If you're just building it for yourself, okay. If you wrote it all, there's no distinction. But for programming in the large, the person who writes it and the person who builds it are not the same person, and they don't always have the same interests, the same things that they want to be able to control. So, yeah, who should be able to make various decisions is an important issue. I've already mentioned configure. Configure is basically all of the decisions are being made by the package author. They get to look at what's happening on the system, and then they decide, well, I've seen that library is there. I'm going to depend on it because it's there. Whereas the person building the package may or may not want that. And it may not be obvious to them that it is going to depend on that library because it's just an opaque shell script. And that was a real issue that Linux distro maintainers had to deal with. Simon.
This isn't my expertise, but what I hear you saying is that, is this one way to frame it? That if the package author is prepared to say, if A exists on the system, I'll behave this way, and if B is available on the system, I'll behave that way. But then the packaging person has to decide whether to install A or B, and doesn't know which to install, and doesn't even know that A or B is necessary. And even if he knew that A or B was necessary, he doesn't know whether A is better than B. Is that right? So that there's a sort of simultaneous equation to solve, because of course installing A might in turn have consequential choices. Yeah. And so if the package author is deciding, and the package, then that kind of makes it impossible to solve that problem, doesn't it? Why wasn't that so obvious?
Yeah, I mean, it certainly makes it harder for the package maintainer. So yeah, so the logic exactly might be that, if A is available, I'll use it. If B is available, I'll use it.
But that's treating whether A and B is available as an immutable thing. But it's
right.
not immutable.
And also it's opaque.
Very mutable.
It's also opaque because that logic is there in the configure script.
Yeah.
But it's kind of not obvious to the person who's building it.
That's a second order consideration. But even if it was completely obvious, it would still be really hard.
Yes. So there's a discoverability issue. It needs to be visible to the decision is even there. It needs to be visible to the package builder. Yeah. And then they need to be able to influence that decision, and that decision needs to be independent of what is actually installed. If you see what I mean, because the package author, the person building the package may decide, yes, I do want to have that dependency on B. In which case, they need to know about that so they can make sure that B is already installed.
That's what I mean.
Yeah, because otherwise, the configure script will go, oh, well, neither of them available. I'll just run with reduced functionality. Yeah. So yeah.
I see. That sounds bad.
Yeah. Yeah. No, and this is why distro package maintenance was such a high effort activity. So. Yeah, so the point is that, then for a new system, you can do a lot better by asking the package authors to provide a bit more information, and in such a way that information is, that encourages that information to be accurate, that it's not just, oh, well, here's my real thing, and there's like some metadata file that I filled in that doesn't really matter. In some way that being accurate is important to the package author, If we can use it to enable automated package management, then that makes it visible to the package author that this is an important thing to get right. So yeah, that was. So this stuff is reflected these days in the fact that in Cabal there's like different places where you can specify different kinds of things, and it's not always obvious to some new users why. A certain configuration choice is made in a Cabal file, and some are made like on the Cabal command line or in Cabal project files. Why is it not just all in one place? And it comes down to this. It's this distinction in these roles between the author of a package and the person building it, and those not being the same person in general. And those distro people wanting to have that control. So we tried to factor it in Cabal, tried to factor it in a more balanced way, because we already had this experience from being on both sides of the fence, of being the author as well as the painful experience of being a distro package manager, packaging maintenance person. So Cabal was, and indeed still is, notionally, a specification as well as an implementation. It is supposed to be a specification-defined thing, and not just an implementation-defined thing. It was notionally agreed between compiler authors and tool authors and package authors. In practice, really, it was the original specification was done between Isaac and a representative from each of the major compilers at the time. So GHC, NHC, Hugs. So they were all co-authors of the original spec. Because the spec it requires something from the compilers. The idea was that compilers needed to opt in to support this new scheme, and it not just be something that's kind of bolted on the side. And there was going to be a bit of standardization, and like every compiler was going to have a common interface for like registering packages and such like. Which
what does the compiler need to do?
Provide GHC package.
Can you repeat the question?
The question was, what do the compilers actually need to do to support the Cabal specification? The main thing is about registering libraries with the compiler. There were different ways of doing it for different compilers, and Hugs. It's trying to you wanted a common way of doing that. So the Cabal specification does actually specify the input format for GHC package, and it specifies the command line interface, or at least part of the command line interface for GHC package. And I think NHC actually did get an equivalent tool, I think, lost in the mists of time. Hugs never did. Hugs, you just had to install things in the right place, and then they would be found. So in a way, Hugs never really did adopt Cabal fully, but it was agreed between all the authors. So yeah, this is why GHC package depends on the Cabal library, because it's the Cabal spec that specifies the input format to GHC package, and it's the Cabal library that implements that specification, and that's why GHC package uses it. So that was the history. So we're going to dive in a little bit more onto what all the various components are and how they relate and different notions of packages. Package is very much an overloaded word in this area, and you need to know by context what kind of package people are talking about. So GHC uses a package environment to satisfy module imports. This is an ephemeral thing within the compiler when you're compiling something. A package environment is a set of packages drawn from a stack or a list of package databases. So there's two things already. There's an indirection. An environment is drawn from a set of package databases. A package database is also a set of packages, but it's represented on disk, whereas the environment is a sort of notional thing, an ephemeral thing within the compiler. GHC reads package databases. GHC package modifies package databases. So that's how that works. And importantly here, the GHC's notion of a package is really a library. And we'll see the distinction when we come to Cabal packages. So yeah, GHC packages are really libraries only. We don't, and those are the ones that are registered in the GHC's package databases, whereas tools, preprocessors, applications are not registered with GHC in that way. Internally in GHC, packages are also called units probably to help distinguish and use less overloaded terminology, but I don't know if that helps. Also, I think unit was the term that was used for backpack, where you really do need a different term because there are lots of instantiations of packages, so you needed a different term. But within GHC, these things are relatively concrete. They're binaries, they're libraries with object code. Whereas, so Cabal, there's two parts to Cabal. There's the spec and the implementation. The Cabal specification defines another notion of a package. which is a unit of distribution of code. So that's obviously not the same as a GHC package, which is just a single library and it's already built and installed. The Cabal spec defines the .cabal file format, and it specifies the command line interface to setup.hs, which, how many people here have used the setup.hs command line interface manually? Okay. So, yeah, it was originally a human interface, but it is no longer.
How many hands came up for the purpose of those in the
I think that was probably about a fifth of the people in the room, I would say. So, not many. In the early days, that was the only way to use it, was via the setup.hs CLI. The Cabal spec also partially specifies the GHC package CLI, not specifically GHC, because it was like, compiler. NHC, Hugs, we're all supposed to have this CLI for registering packages. And the input format for GHC packages, which is the installed package info, that is also specified in the Cabal spec. And again, from the original context, in which at the time where there were multiple compilers, and we didn't want to be seen to be preferential to one or the other, the Cabal spec goes out of its way to be trying to be agnostic about different implementations, and it's supposed to be a not compiler-specific design. But as we all know, certainly the Haskell compilers that were around at the time are sadly no longer, and one or two have come and gone in the meantime as well. There's a question in the back over here.
Here as well.
Oh, okay.
So let's start.
Yeah, let's start. Fred.
Quick question. What's
Yeah.
the function of the setup.hs file, and when should I be using it?
We will come to that. So
Thanks.
Yes, just a quick clarification question. So you're talking about GHC packages, right? And then Cabal packages, and are GHC packages sort of the libraries that you define in a Cabal file, or?
Yes, yeah.
Okay.
The closest relationship is that, and we'll come to this a little later as well, is that a Cabal package is a collection of components, and a component, when that component is a library, corresponds to a GHC package once it's been compiled and built and installed. That's the connection. So the Cabal library, it's an implementation of the Cabal specification mostly, plus notionally the Cabal spec has been extended. I don't know if it's in practice been updated, but sort of notionally there's still that kind of distinction between a spec and an implementation, even if it's not necessarily all written down in a particularly formal way. So the Cabal library provides data types, parser, pretty printer for the Cabal file format and the GHC package input format. It actually also has a registry of all the Haskell extensions, which again is an artifact of the early days. That there were multiple compilers, and each compiler had their own set of language extensions, and we wanted to be able to declare in Cabal files what language extensions you were using, and those wanted to be shared between compilers when they could be, so that if two compilers both implement the same extension, then you can say, well, my package, you don't want to have to declare my package works with this compiler, with that compiler. The idea was you wanted to be able to say, my package needs this language extension and this library. And if that's available on NHC, brilliant, it'll just work. Rather than having to say, I've tested it against specific compilers, it was supposed to be just declaring dependencies. And language extensions are dependencies, if you look at it sideways. So all of the language extensions from all of the Haskell compilers are kept in the Cabal library, which is one reason why when new language extensions are added in GHC, they also have to get updated in the Cabal library, which is something sometimes it has lagged sometimes. If you look, obviously, 20 years later, GHC is the only one still standing, and it has a list of language extensions that goes on for pages. But if you look in the list in Cabal, you'll still find like 2 or 3 which were only ever implemented by Hugs, I think, and never by GHC. Some extensible records feature from the early days. So there's still one or two which are not GHC specific. So that's an interesting relic. Those first two bits are now split out into the Cabal syntax library. Cabal the Cabal library has been split relatively recently. And then the implementation of the setup command line interface is also in the Cabal library. Use it in the so-called simple build system. And the simple build system supports multiple compilers, at least notionally. Its architecture is there for multiple compilers. Obviously, again, in practice, people only use GHC. And the Cabal library also provides the hooks and utilities that custom setup.hs scripts rely on. And yeah, these days, setup.hs is almost always used via tools and not manually. But it still is there, which is an interesting wart we'll come back to later. But yeah, in the beginning, that was the only way to use it. The original Cabal specification and talks and stuff, they describe it in terms of, well, you're going to be using setup.hs in just the same way that you use configure, make, install. One mirrors the other. So Cabal install is a command line tool, not a library, of course, and it is intended as a user-facing tool, developer-facing tool, not unlike the setup CLI these days. And it is implementation defined. There's no specification for it. But that's kind of okay because in principle there can be multiple alternatives to Cabal install. And indeed there are. Stack is a thing. It's a sort of combination of build tool and package management tool, which at the time was a bit odd, but is more common these days if you look at other languages. Historically, you would have a much clearer separation between build tools and package tools. But actually, I think it's probably right, because when you want to build your own code, it depends on things, and so you've got to go and get them. So, package management kind of comes in rather naturally. The modern incarnation of Cabal is based on a notion of projects, which is an environment for building a bunch of related packages. Cabal install is particularly pushes you towards a solver-based workflow for building projects, but you can also freeze things and update manually if you like. It supports mostly reproducible builds, not as much as Nix, but much better than it used to be. And it fetches Haskell dependencies from Hackage, the public one or other Hackage archives, source control, Git, repos, and local remote tarballs. Excuse me. Oh, did I skip over one? No. So Hackage is another very important component in the system. The archive format of Hackage is notionally defined by spec. I'm not sure if it is formally written down in a way of a specification, but sort of notionally there's a spec there that multiple tools can. I mean, in this case, it's really important that multiple tools agree on the format, because you've got one side that's serving it and one side that's consuming it. So, and there need to be many implementations there. So, it being a sort of at least notionally defined by spec is important. The format is designed so that it can be just a static bunch of files served over HTTP, which is really useful. It's used by Cabal install and Stack and other tools. The archive format provides an index, which is really important for package management. It provides the actual source tarballs. These days, well, I say these days, it's been probably at least 5 years now. It has a security system, which is partial. It doesn't involve author signing, but it solves a bunch of other security issues, which in particular supports trustless mirrors, which is quite cool. Hackage has gone down, of course, from time to time. which the website goes away, but that doesn't necessarily interrupt people's typical workflow because the mirrors are used automatically by Cabal install, and so as long as the mirrors are still there, there's no interruption of service, which is quite nice. And it has a sort of an interesting design of an append-only index that's intended for incremental updates for being able to mirror or sync or download the index. And we'll come back to details on these things later. Hackage server is an implementation, so not the only one, because there's static. What's the one that? Say that again. Foliage.
The thing that goes on trees. Don't ask me why it's called that.
So there are multiple implementations of the server side, and I think foliage is a static generator, right?
Yeah, so it generates. It's uses shape to generate just a static website that can be hosted on GitHub pages.
Yeah, or any HTTP server.
Boring HTTP server.
Yeah.
Would you please repeat the comment?
Foliage is an implementation of it's a static generator for a Hackage archive, Hackage format archives, which can just be hosted on any generic HTTP server. So Hackage server is a relatively fancy thing with lots of dynamic stuff, but you can have just very simple static archives as well. And so the one that Michael and I were just mentioning is one that's used within IOG. So it's IOG uses both the public Hackage to get dependencies from everybody else, and uploads all of the internal components to an internal Hackage archive, and then Cabal uses the combination of the two to build things. And that idea was part of the original idea of how the Hackage archive style ought to work. That you should be able to have a public one, but you should also be able to have private ones. In practice, it's taken quite a long time for people to write the tools to make the private ones easier to use. So anyway, Hackage server is a standalone, is an active, not just a passive bunch of files. It's an active server. Like the public one is hosted behind reverse proxies and stuff. But it's a big Haskell application that keeps a lot of stuff in memory. It has lots of features beyond just serving the archive format. It obviously has a website. Question over here. Yeah, what is the purpose of post-release editing of package metadata? That's a surprisingly controversial feature, and I will talk about it in more detail later, precisely because it's interesting and it's also controversial. And it was first demoed at Zurihac 10 years ago. So, nice connection there. So the Hackage server has a concept of users and permissions. You can have maintainer groups and who's allowed to upload which package. It supports uploading packages. It has package browsing and search. You can upload Haddock documentation. There's automatic doc builders that go away in the background. Those are separate clients to the Hackage server, but the Hackage server accepts uploads of Haddock documentation, and it serves the documentation. And it's obviously used for the public instance. And it is possible to run your own instance, or you can use something like Folio, which does just the static stuff, which doesn't have docs, doesn't have. Actually, maybe Folio does have docs.
It has a base. It doesn't yet have Haddock. It has a basic sort of website that has a package listing and stuff. We would like to have Haddock, but not.
I mean, the nice thing is that the different implementations don't have to do the same thing in terms of like their websites. The only bit that they have to agree on is the archive format, which is just the index and the tarbles. So stuff to do with like package search and HTML. That's completely up to each implementation to do what they like. So it's not constrained that way. There are also Stack and Stackage. Stack is an alternative to Cabal install. It has a different philosophy. Instead of being Instead of a solver-based workflow, it encourages a workflow based on pre-canned, curated collections of packages. And instead of using a solver, you're encouraged to choose specific versions of your packages and particular dependencies when they differ from the ones from the public collection. So you pick exact versions, and you're responsible for making sure that those work. It can also call out to Cabal install for a solver workflow, but that's not its intended workflow. It's not the one that it sort of, it's not what it was there for. And then Stackage is sort of an alternative to Hackage, but not quite. It's kind of like a downstream from Hackage. It's not trying to replace Hackage, and it hosts curated collections of subsets of Hackage. I think technically you can actually upload things to Stackage, but the intention, at least with the public one, is that the Hackage is the upstream place where packages are uploaded, and Stackage is looking at some collection of them that are known to work together and checking that they do work together. So each Stackage snapshot has a single version of each package, whereas the public Hackage has all the versions that have ever been uploaded. And the intention is that all packages in a Stackage snapshot should work together, and there's various CI systems in the Stackage project that try and ensure that. And it uses its own format. It doesn't use the Hackage archive format. It uses its own format and its own protocol, which I think is based on Git rather than HTTP. Just serving the Hackage archive format is just files served over HTTP in a very straightforward way.
Yeah, well, there's also Flora.pm, which I don't know if you were going to mention it. Flora.pm.
I don't know this. What is
Okay,
it?
well, you can find out about it on the weekend because it's one of the featured projects, one of the projects that were proposed for Zurihac.
And what actually is it?
Well, yeah. So it looks. So you see a package index. I
Okay.
don't know if it actually can serve packages, but it's supposed to be an alternative package index, alternative to Hackage.
Okay.
But it actually relies on Hackage to some extent for now. Anyway.
I will be interested to find out more details.
I think it's a front end primarily at the moment, at least. This is Hikata's project, and yeah,
There was another
Lightning
question.
on Saturday, by the way.
What's on Saturday?
The Lightning Talk Forward is on Saturday.
Okay. All right.
Oh yeah, exactly. Sorry, that's what
All right.
I just wanted to say that it's basically a front end that is supposed to make browsing Hackage nicer.
Okay.
And yeah.
Good. Yeah, I mean, these are all tools that could do with more love. And as I said at the beginning, that's partly my ulterior motive for this talk, to try and tempt you away from GHC and to come and help with some of the other tools. So we're going to dive into a bit more detail about GHC and GHC package and GHC's notion of packages for the moment. So GHC's concept of a package is a library. It's an installed package, and it's a binary library built against specific dependencies. So this is why I said earlier it's very concrete. And as I said before, within GHC, it's also called a unit, which I think is because of Backpack. So I mean, obviously in GHC, a package also really includes like the actual binary files, .a files, .so, whatever, depending on the platform. But it's also then information about that library. I mean, in some sense, the library is literally the binary files, but GHC's concept of a package involves knowing something about that package, and that's what the registration information for packages is, and it includes quite a lot of information. In particular, all the stuff that GHC needs to be able to compile and link against the library. So in particular, it includes what all the modules that are exported by that library. That comes from the library registration information, both the exposed and the non-exposed modules. it lists all of the other dependencies on other registered libraries, so that GHC can recursively go down the tree and then link everything together, or find all the HI files for all of the for everything. All kinds of other low-level gubbins, linker flags, things to do with C libraries, et cetera, et cetera. Question over here.
I believe it can also include executable and executable, right?
Oh,
package?
no, I don't think so. I think the GHC registration, with GHC package in the package database is just libraries. I mean, you might be able to fudge it and put something in there, but I don't know that GHC wouldn't be able to do anything with it.
Not the actual binary executable, but the yeah. Go ahead.
I think there's two things here. There's the Cabal file, but that's not what we're talking about here.
Yeah,
That's the package description. The Cabal file syntax can include libraries, executables, test suite, and all this. This is, however, a GHC specific thing, the installed package info, as we call it. Which, sorry, Duncan.
So when you first put a slide out, 4 slides ago that said GHC uses the word package for something different to what Cabal uses, I was thinking, oh, that's rather confusing. I didn't know that. Shouldn't we use a different term? But what you're saying here is actually it's often called unit. So maybe we just consistently, just make a policy decision that GHC should just call unit for its concept of, and then you can say GHC's concept of a unit.
Right, but then I would have to
maybe we
explain
should
what a
just do
unit
that
was.
consistently. That would resolve your problem, right? But then a unit doesn't have an executable like a Cabal package does, right?
I was still thinking of package.
Yeah, it's very, very confusing to use the same term for 2 different things.
It is, but I mean, and I think probably the right thing to do is that right? Is to say, GHC calls them units. But still, then you've got to say, well, what are these things? What is GHC's notion of a package? It's not a package, it's a unit. So we still have to explain it one way or the other.
Right, but then you could consistently use that terminology.
All right, consider every time I say package in relation to GHC, we're talking about units.
So sometimes when I'm trying to reproduce a bug, no matter how much I try, I need multiple Cabal libraries to reproduce the bug, which is a bit frustrating. And usually what I end up doing is having as small example as possibly you could run with Cabal, but you can't really check that into the GHC test suite. So it seems like you have to sort of distill it down to the GHC package level. And I'm wondering, is that actually possible to do with just GHC itself, or do you actually need a build tool in order to produce these packages here?
The input to GHC package is a human readable text file. You can just fill in the details. You can look at the examples that Cabal generates for you, and you could just change it, write your own. I think the way that GHC's build system generates the input to GHC package is completely different, and it has some file template substitution business.
Okay.
Because you're just substituting in locations and directories and module names and dependencies and
You could quickly show one for base or something. Right?
Let's have a look.
Okay, so I'm getting the feeling that it is technically possible, if not a bit
We do that in some cases.
verbose to do so manually.
There are some tests that actually do this.
Oh,
A few, not many.
cool.
There are actually some tests in the GHC test suite that actually provide a .conf file, one of these, the textual representation of this installed package info. I think GHC package describe
that's the
base, and I think that will, or some such.
I was trying to remember whether it was display or describe.
Describe, yeah. And so this is the GHC package utility, which is GHC's implementation of the HC package interface, and describe will dump the textual representation of this installed package info.
So the name of this package is RTS. Its version is 101. Its ID is also RTS. We'll come back to what IDs are in a minute. That's an important concept. So it's got a bunch of stuff in here that is not strictly needed for GHC to compile things, like the license, the maintainer, the description, but then other things which are absolutely crucial, like the fact that it contains these 2 Haskell libraries, HS, RTS, and CFFI, and then a bunch of extra libraries which are not Haskell libraries or not GHC compiled libraries, system libraries, pthread, etc. Include directories, specific include files, and then a whole bunch of linker flags for special magic that the RTS needs. And so, this one is definitely generated in a more custom, this one is not generated by Cabal, I think. It's generated by the GHC build system in a different way. Because Cabal doesn't know about all these kinds of crazy linker flags that the RTS needs.
Sorry, so the HS libraries above correspond to libraries in the Cabal files?
Typically, yes.
'Cause
Yeah, so
how does the mapping happen? If you have two libraries within, like two components in a Cabal file, then...
each component in a Cabal file will give you a separate package.
Right.
This is a weird package, because it's the RTS, in that it has two library files, two binary library files for the same unit.
Perhaps you could quickly show base as well. That would be that might be a useful, because that's more normal library.
Yeah, I thought I'd start with a weird one.
Yeah, that's an RTS is an interesting one as well, but that's.
So what has it got? It's got, of course, a lot of modules. So a very long list, but let's find the HS. Lots of modules, hidden modules, HS libraries. There we go. So this one, the name of the package is base, and the library ends up, so the actual file name of the .so or the .a library is with, obviously with the extension omitted, is HS base. It's just a convention that GHC uses to always put HS on the front of every library to try and avoid clashing with system libraries, even though they've all got versions these days, so maybe it doesn't matter. So just a GHC convention that Cabal follows. So yeah, and the library name includes a version number. Probably for historical reasons, it may or may not be necessary these days.
I think in some cases it may include the key as well, right, or the package ID, because otherwise you might have multiple, okay, well, you'll get there, I'm sure. Yeah.
Let's have a look.
It's a Cabal build library.
So do I have network in here? I think I did.
I think only Cabal built libraries would, because
yeah,
we
exactly.
don't, the boot libraries
what
don't
have I got
have
here?
interesting keys or IDs.
Have I got network? I thought I did. Oh no, sorry, that's somewhere else. Doesn't matter.
So actually, it might be useful as well to say something about the fact that there are multiple package databases. I'm not sure if that can.
I will get to that.
Okay.
Yeah. So yeah, we were saying. So it has all the information that GHC needs to compile and link, and it has other metadata that GHC itself does not use, but it's kind of handy to have, and other tools can report it. In particular, Cabal info can tell you about installed packages, even if there's no corresponding source package.
Question from Gergo Online. What is a Haskell library?
What is a Haskell library?
Very philosophical.
I don't know how to answer that. I need more context in like, because of what I said, there's like different notions of package.
Maybe it relates to like HS library with a dash.
So yeah, when we were looking at the base,
You mentioned you said Haskell library when you read that. So that
so this thing, so the HS libraries is telling GHC the file names to link against for the actual Haskell binary compiled version of this unit. And so that is the file name that GHC will link against, and so that gets turned into a linker flag, which will be like -L, HS base, and the linker will go and search for a .a or a .so file. So that would
LS, the librator, just to show that that file exists.
yeah. So the library directory. So that's the search path where
For
we
people
will
online,
expect
Ben
to
just asked
find-
from the LS, the library directory.
Yeah. Oh, sorry. Thank you. So we're going to have a look at.
I also got clarification on the question that it was, in fact, with respect to the HS library that he was asking the question.
Okay.
So you've answered it.
Good. So okay, so we just saw in the registration file for base that this directory was where it said its library dirs was. So that's a search path for where to find the HS libraries. And indeed, here we find it. Here's lib hsbase. So that's the full with .a. And there's also a _p.a for the profiling version. And then there's another one which is a .so for the shared library version. Ah, and there's another one. There's a just .o, which is sometimes used by GHCI. So actually, how many have we got here? 1, 2, 3, 4, 5 different variations of the compiled artifact of the code for base. And then also all of the HI files. So if we went back and looked at the description, it so happens it's the same directory, which is why we found them there. But the import dirs is where GHC is going to go and look for the HI files, which conceptually is different from where it should look for the library binary files. Oh, and dynamic library dirs is different, but in this case, the same directory. All right, that's probably enough of this.
Oh, Duncan, one more question.
One more question.
Could you maybe say something about separate compilation? So there are these HI files, which I guess are the interface files.
Yeah.
But Haskell doesn't support separate interface files in text. So how can I release a package without releasing its source code somehow? Just its API? Is that possible?
In principle, you can distribute. So
I have
you've got a mic. So that.
The people in the room may not hear.
Oh, I'm sorry. So my question was regarding separate compilation in Haskell. Is it possible to somehow specify the API in a separate file so I don't have to always ship out the source code with my implementation?
So in principle, you certainly can distribute binaries and binaries of Haskell libraries. And actually, that's exactly what Linux distros do. So if you install Fedora and you DNF install one of the various Haskell libraries, what you will get is just this stuff without the source code. And yes, you can load that up in GHCI, you can compile against it, that will all just work. In practice, it's pretty much only Linux distros that do that. No one else ships binary libraries, really. They ship applications, binary applications, but not libraries. It's just such a pain in the posterior. It's quite fragile to, it depends on so many things. It has to be, it can only work with the exact same GHC version, the exact same, you've frozen all of the dependencies now to exact versions. There's no choice or flexibility left. Whereas distributing as source is just much, much more flexible. And it's only developers that need this stuff, and they can compile things on their own machine. It's fine. Distributing binary applications, that's really important. But distributing binary libraries, is that so important?
So if I don't want...
Nix does it too, right, with caches. So it saves you time that way. So it's not impossible. It's just it tends to be rather specialized circumstances in which it really makes sense. Because you've had to freeze exact versions of everything.
But can I then, from an HI file, just get out the functions that are in that module or set of modules?
You absolutely can. If you run GHCI or HLS and ask, what's exported by this library, you don't have to have the GHC is not looking at the source code to answer that question. That's just coming from the HI files.
Cool. Thanks.
Or perhaps from the package registration as well.
Just a quick note that one of the reasons why it's so fragile is that GHC does not have a stable ABI. The calling conventions are somewhat unstable, and moreover, we do lots of intermodule and even interpackage inlining. So even small differences. Yeah, so Duncan will get there. That's yeah.
Actually, it's not really a topic I was going to talk about, but GHC does actually have a hash of the ABI, and that's an extension beyond the Cabal spec that got included into GHC package registration. I think it was a particular project that Simon Marlowe was pursuing a few years ago of trying to make it easier to swap out, in other languages, particularly C, you can write a library like glibc or something, and then change that as a shared and have that as a shared object, and change that without having to recompile the application. You just swap the library and rerun the application. And that might be nice to be able to do in Haskell. It's quite hard, and part of the reason is to do with not having stable ABIs. And so Simon had a project to try and make it possible, at least in a kind of opt-in way, to try and be able to fix ABIs. It really restricts what you can do. And to be able to track if you've done it correctly, you need to know what the ABI is, which is what this hash is about.
I had a quick question about the ABI.
Yeah.
What does that hash include? Does it just include the calling convention of GHC, or does it also include all the exposed, so that the interface of that library did not change?
So I think GHC can compute the ABI of individual functions, and I think in a pragma you can declare, I want GHC to tell me if I've broken the ABI of this function. So you can kind of ask it what its current ABI is, or at least the concept that Simon had. I don't know if this actually works in practice, but I think the concept he had was ask GHC what the current ABI is, and then, right, stick that hash back into the program, and then GHC tell me if I make any changes that break that ABI. The ABI of the entire package, I think, is computed by taking the tree of all of the modules, all of the things exported, and hashing those all together. So it's the hash of all of the ABIs all the way down, of all the stuff that's exposed, that's public. Let's move on. So yeah, so all of this stuff in that we were just looking at in the GHC package display comes from this type that's defined in Cabal syntax, installed package info. So you can. And there is some historical cruft in all of this because things have changed over the years, and it historically has supported more than one compiler. This is an important topic which I wanted to get to, and then we can pause for coffee. There are two kinds of package identifier floating around. Just like we've got multiple notions of a package, there are two important kinds of package identifier. But perhaps we should call one of them a unit identifier.
Isn't it called the unit ID?
It is, yeah. Within GHC, it's certainly called the unit ID, yeah. But Cabal also calls it the installed package identifier as opposed to the source package identifier, which also is suggestive of what the purpose of these things are. So a source package identifier is relatively straightforward. It's just a name and a version. It's what, as a human, what you think of when you think of, well, that's a package. It's, base 4.13.0, network 3.1.2.7. So, that's nice and simple. That's the source package identifier. That's, the names of the tarballs, it's the name on the websites, etc. And then you've got this thing called the installed package identifier. That's what Cabal calls it, and as we were just saying, GHC calls it the unit ID or the unit identifier. And that is just an opaque string with no particular requirements on its structure. Whereas, a source package ID is a name, and that has a particular syntax. There's a particular set of characters you're allowed to have in a name so that we can make sure that they're portable to lots of different package management systems, to Debian, to Fedora. You can't use, I'm not sure if you're allowed to use Unicode in them, because probably Debian doesn't allow that. I don't know. There's restrictions, there's syntax restrictions on it. And then a hyphen, or a minus sign, and then a version number, and the version numbers have a syntax as well. So it's a tightly constrained syntactic thing, the source package ID, and the installed package ID is just a big string with no interpretation on it. And so how that installed package identifier is produced is up to the package management tool, and we'll see how that flexibility gets used.
This is
It's
unit ID, nothing to do with Cabal.
No, it is Cabal. Cabal is the one that. So the question was, who's deciding on the package identifier, the unit ID, the source, the installed package identifier? And the answer is, it's actually the build tool that decides it. And so GHC is not interpreting these strings. No. It's just using them as as just keys in maps.
Just destroyed my mental model. You said this is GHC's. This is a GHC unit ID, and other things might have something else.
But
you're saying Cabal makes them up.
Yes.
That seems like. Is that right?
It is.
No. Why? I mean, how can it be GHC's unit ID if Cabal makes it up?
It's a thing that GHC calls the unit ID, but its structure, its value, how it's derived, is not chosen by GHC. it's chosen by the package, the build tool and the package management tool.
So what GHC says?
GHC just relies on these things being unique. That's what it relies on.
Yep.
So yeah, the installed package ID, unit ID is the unique identifier that GHC uses to identify installed packages.
No, the Cabal uses to identify.
It's what okay, maybe, but it is also what GHC uses in. It's what GHC uses internally to identify a package in its environment, in its package databases. When we've got multiple packages floating around, that's the unique ID, and in particular that means these days it allows for multiple instances of the same source package to be installed at the same time, which is actually a big feature, and that was a change we made. Again, probably about 10 years ago now, maybe slightly less. And we'll talk about that in more detail after the break. An example of why you want that is because you might want the same package installed against different choices of dependencies, or funky backpack things, which I won't have time to go into.
All right, so I'd like to check my understanding a little bit. So the output of the Cabal build tool is installed in the package databases.
Yes.
Locally.
Yes.
And those include this number, which is generated by
This
the Cabal
identifier.
build tool.
Yeah.
And those package databases are indexed by GHC package.
Yep, by GHC and GHC package
Which
using the identifier.
And GHC package is inspecting literally the file system to find what packages there are available locally for it to use.
GHC and GHC package share a package database format, which is something we'll come onto in a couple slides' time. Yeah.
Right. So the package database exists on the file system,
Yep.
and it has Cabal installed putting things there. And
GHC package puts things there.
right.
Yes.
Okay.
So we were talking about package identifiers. We're going to talk a little bit more about this stuff. This is the kind of core concepts of packages within GHC and how Cabal relates to them. So we talked about these opaque identifiers. So okay, now we need to talk about package environments. So a package environment is a GHC concept, comparatively recent, and it's a set of packages identified by their installed package ID, aka the unit ID, and a package environment is hopefully closed and coherent. Closed, it's dependencies all the way down, and no dangling dependencies, so that you can actually compile and link things. And coherent, I don't have a precise definition for that, but something where you're probably not going to get type errors that you didn't expect. That usually means that you don't have multiple versions of the same package within a single environment. And this is used by GHC, at compile time to resolve module imports, and look everything up during compilation, so that it knows which packages are actually available in the context of building some piece of code. And it's an ephemeral thing that exists, within GHC while it's compiling. Constructing one of these environments is not as simple as one might hope, given that it is conceptually very simple. It's just a set of packages. It is a package environment within GHC is selected from a stack of package databases. Aha, another concept, package database, which we'll get onto in a second. And there are various command line flags which which you can use to ask GHC to select packages, units, to include into the environment. And those can be by the installed package identifier, the unit ID, these massive long opaque strings, or by source package ID. So it's a little bit flexible there. In the end, it's a set of packages by installed package ID, but you can, when you're selecting the packages from a larger database, you can ask for packages by name or name and version, not just big opaque string. So GHC does know about package names and versions. It's just that the package, these package environments are sets identified by, or maps, keyed by the unit ID. And there's a unfortunately complicated and heuristic shadowing algorithm that GHC uses to take all of your instructions of this package, that package, and to turn that into a hopefully coherent and closed package environment.
Why does GHC need to know about package names and versions? I can think of two possibilities. One is like error messages and the other is package imports. Is there anything other than that?
I think those are two good reasons. And the other is so that you can ask for packages by package name.
When do you ask for packages by package name?
You can literally run GHC-package network. And that will bring the network package into my environment in GHCI. And perhaps that's convenient, but perhaps there are better ways of doing that these days. So this is partly a historical feature, because historically we didn't have these crazy unit IDs.
But if
we just identified things by package name and version. And in that case, it was really important to be able to select by package name.
And if there are multiple units with the network package name in the database.
That's why it's a complicated algorithm.
Right, that's the shadowing algorithm comes in. Okay.
And that is something which I think, in principle, we could abolish. This is an opportunity to reduce complexity by getting rid of some historical cruft and saying we don't support certain historical use cases anymore.
But would that include package imports?
No, you could still have package imports because you've already selected a package environment by the time you come to have package imports.
Right.
This is decided up front when GHC is being invoked, or at the beginning of a compilation, and then a package import is something that happens within that environment. So they're not incompatible. The package imports do not influence the choice of package environment. Okay, package databases. So we've got these two different concepts, package environments and package databases. We'll come to why do we have these two concepts in a second. So a GHC package database is another set of packages. Again, it's really a map with the unique primary key being the installed package ID, unit ID. Package databases do not have to be closed. Dependencies in one database can be satisfied from other databases. In particular, well, we'll come to it in a second. In particular, you typically have at least two, some project-specific database and then the global database. And like base and RTS are in the global one, and then some project-specific one has dependencies on base, so they're not closed. Or the one at the bottom might be closed, but the ones higher up the stack are not closed. Although once you stack them together, then maybe the combination should be closed. Yes, it has an on-disk representation, whereas environments are ephemeral things. These are concrete things with a file representation. Question over here.
Yeah, you're saying environments are ephemeral, but there are these things called environment files.
Yes,
right?
and we will come to that.
Okay.
There are multiple package databases. As I said, there's the global one, which is system-wide in multi-user Unix installations. And it always contains like base and RTS and the things that are bundled with GHC. There's a user package database, which is less used than it used to be. This used to be like another really important one. It's less so these days. And it starts off empty, when you first install GHC. And it's per user. And so on, classic Unix, university systems, the sysadmin would install GHC, and that gets you your global package database, and then each student gets their own user package database. Obviously, less important on single-user systems. And you can have other specific package databases which have to be specified on the command line, or environment files, which we'll come to. So package databases have an on-disk representation. That's a directory with a bunch of files in it. In particular, there's the package ID.conf. So the package ID in this case referring to the unit ID, the great big opaque string. So okay, there is a restriction on those strings. They have to be strings that are legitimate as file names. So you can't play any weird games with Unicode representations, otherwise things won't work on Mac file systems or something. But that's the responsibility of the package manager. So those are those human readable registration files we looked at earlier. Then there's a binary cache of all of that information. And GHC only reads that cache. GHC package creates the cache. And there's a lock file for concurrent modification. So the binary cache is really important for efficiency. So when GHC starts up, it doesn't have to read 10,000 conf files, which are, they need parsing. It's a text format. So GHC can just read this cache. It has an index. The cache gets written by GHC package. And also a really nice feature of this design is that like the GHC library and the API and the compiler don't depend on Cabal. Only GHC package depends on Cabal, because GHC package reads the human files, runs the parser, generates the binary cache, and GHC just reads the binary cache. And so we managed to avoid a dependency on Cabal. Originally it did, and it caused a lot of pain, and we managed to refactor it in such a way that GHC no longer depends on Cabal unless someone's broken that in the last 5 years.
So the question was, these conf files, human readable conf files, they constitute
they are the canonical
what you called package database.
Yes,
they're
the
conf
canonical
file
information.
Is one package database or a collection of conf files somehow?
A package database is a collection of these conf files.
Oh.
So there's this dollar is supposed to indicate that there's one of these for each package identifier.
Oh, so you mean a package database would be a directory, full of conf files?
Yes.
That is one package database.
Yes.
Different directory, different package database.
That's right.
I see.
Yes.
Okay. Right.
But the format also crucially relies on this cache file, which is called a cache file, but in fact it's necessary. And if you don't have that cache file, GHC can't read it, can't use the package database.
Oh, and there's one cache file per package database.
Per package database,
that
that's
lives as a peer to all of these conf files.
Yes.
I see. So it's not a single cache file across all of the package databases together. No.
No. Let's
have
thanks. A look at where we were a moment ago. Let's see.
Related question. To recreate the cache file, I assume you only need the configuration files, or do you need something else?
Correct. Yes.
Thank you.
Package DB. Oops, I'm typing but looking the other direction. So this is the package database, the global package database that comes with this version of GHC installed on my system, and it has a load of conf files in it. Now, okay, this is a digression here, but these have all got short package identifiers because it was GHC that chose these package identifiers, GHC's build system, that chose the names of these unit IDs, whereas the unit IDs that Cabal chooses are big, and we will see, hopefully if we have enough time, why that is. So these ones are just the same as the name in the version. That's okay, you can choose the ID to be the name in version, so long as that's unique, that's okay.
Unique within this package database?
Within this package database and any package environment you might want to construct. So if you might want to combine it with any other package database, they ought to be unique with those two. Which is why Cabal does not, you can install a new version of Unix 2.7.2.2, Cabal can do that, and it will install it into a different package database, and it will not call it that name, it'll call it Great Big Hash, so that it doesn't clash with this one, and it doesn't clash with any others. So this contains all these conf files, those are all the human readable files, and there's the package.cache. And GHC package, if you call GHC package recache, it will read all the text files and write the package cache file. Question over here.
I was wondering, when would you be combining package databases?
Every time you invoke GHC, because typically, so if you just run GHCI, by default, you're going to get the combination of the global and the per user package database. If you're running Cabal within a project, you'll be combining the global with the, you'll be combining 3 package databases, the global one, the Cabal store package database, and a per project database. So basically all the time, you're using multiple package databases and then selecting an environment as a slice from that. So historical note on something that people used to call Cabal hell. Any problem that people encountered, they just blamed it on Cabal and called it Cabal hell. But particularly, the most common cause of disgruntlement, let me approach it in a different direction. So yeah, let me do it in the order I've said here. So historically, package databases and package environments were the same thing. There was no distinction. We didn't have this additional indirection. So it was the GHC packages which defined the whole environment. And you can see that historical, that history reflected in the fact that there's, for example, GHC package and GHC still have this notion of packages that are exposed or not exposed as a thing you can change within the package database, which is basically redundant these days, but that comes from the era in which it was the package database that defined the environment, and so you might want to have some which were not exposed, like GHC prim or the GHC API, so that when you start up GHCI, you don't automatically get these things in scope. But anyway. And historically, there was this constraint that there be at most one version of each source package in each package database, or stack of databases. And the result of that constraint was Cabal hell, in that installing new packages could break old ones. Or you might have to force the new package to be consistent with the set of packages you've already got installed, because you can't change, you don't want to break or change the existing ones. And even if you could do that, which sometimes is impossible, then if you do that, the result that you get at the end after a sequence of installations depends on the order in which you ask to do it. If I ask to install everything at once, I might get a different solution than if I ask for A, B, C, and D in a particular order, because you're forcing constraints. There's fewer choices if you do them in a particular order. And that makes people grumpy because it's non-deterministic. They can't predict what the dependency is going to end up being. Question at the back here.
Exactly what led to the creation of Stack?
Cabal hell was one of the motivations for Stack, yes. And their approach to this problem was to say, there shall be only one version of everything ever. And that will solve the problem. Whereas we took a different approach, which was to say that, okay, there's this constraint. There can be at most one version of each package in each database. Stack went with that constraint and said, let's extend that to the source level and say there's only one version of anything ever. Our approach was to say, no, that's wrong. That's not reasonable. You can't force us to just have one version of everything. You must allow multiple instances of the same version of the same source package, which is, of course, what Nix does, right? So we tried to steal some of the good ideas from Nix. And so this leads to a design where you have source and installed package identifiers, which are different. And it means that you have, if you've got lots of instances of the same version of the same package installed, and just generally lots of instances available, you then still need an environment when you're actually compiling that's some reasonable subset that is coherent. So that means you need a concept of a package environment. That's where that distinction comes from. You're kind of forced to have it. As soon as you say, well, I can have multiple instances so that I don't break existing things, you still need to be able to compile things with one version of things. So that means you need a separation, you get environment. And you'll see around in GHC there is some cruft from the kind of pre-environment split. And also Backpack relies on this. It was a convenient coincidence that at the time that we were trying to solve this Cabal hell and bring in kind of Nix-style package management, Simon and other folks working on Backpack, they ended up using the same design of having, you can have multiple instances, multiple units, because the same Backpack module can be instantiated many different ways, and that neatly fits with this idea of even ordinary source packages being installed against different versions of their dependencies at the same time. I said we would get to package environments. So what environment do you get when you just run GHCI? You would like something reasonable. And if you've got a package database which has zillions of packages and zillions of versions, it's not clear what you ought to get. So selecting a coherent environment from the package database really wants tool support. It's not something you want to be doing manually. And so to facilitate that, we added a mechanism into GHC some years ago to be able to have package environment files, which are just ways of persisting all of the information that GHC uses to construct a package environment internally. So basically it's a subset of the GHC command line flags that are used for selecting packages to construct an environment, but you put it into a file. So here's an example from my system. There's a .ghc, Arch, platform, etc., blah, 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 environments, default. And this is the contents of it. It says, clear the package database, add the global package database, add this specific package database, which is the Cabal store package database, and then a whole bunch of package IDs. Now these package IDs, this is the same as the command line flag, -package ID, which is the unit ID. So their GHC is calling it package ID despite it being a unit ID, which is probably my fault. The original flag is also -package. So the package ID, these are the unit IDs, but as we saw before, the ones from the global package database just use their unit ID as the source ID as their unit ID. But here's an example of one that's in my default environment, which clearly comes from my package store, because this is one that Cabal invented. And as you see, it's got network, version, and then a great big hash. So that's one of the ones that Cabal cooked up. And now that is in my default environment. So when I start GHCI, I get all the stuff from the global package database that you normally get, base, etc. And I've added something custom, because I probably at one point did Cabal install lib network, so that when I start GHCI, it's part of my default environment. And that's the mechanism that GHC provides for managing these. But the idea is that, I think, so this is a mechanism that GHC provides for tools to construct these environments. So you're not really expected to construct these environments manually, but it's a mechanism that allows package management to provide to GHCI a kind of, hopefully, a convenient user experience, so that you can just run GHCI and have a reasonable set of things available. And you clearly want tool support for being able to choose and modify what's there. So the mechanism that GHC provides these days is that you can specify one of these environment files on the command line by file name, or just by short name, in which case it's looked up in this environments directory. You can specify it by a shell environment variable. You can also specify it by a local file in a directory. And then there's some default. So you can have named environments. You can have environments by file name, environments specified by shell context or directory context. So it allows tools that want to use this to let users have an experience where you just CD into a directory and run GHCI and you'll get one environment, and you have a shell open and you CD into a different directory and you'll get a different environment. And maybe that's what the package management or build tools want to do. Or an idea from Nix is that you can have, if this is being part of your environment, and you just launch a new shell, and now the shell tells, the shell environment tells GHC what package environment it wants to use. So again, you can have, you can enter a shell and get some environment. So GHC will use this, but it has to be constructed by a tool. Yeah, we're pretty much at time. Maybe we should leave it for any other questions.
Now, if I type GHC package list on my computer, you say, well, it'll use the global environment, but I think there may be more than one because it says it's in some GHC up directory. So that's special to GHC 9.4.5. So it seems that GHC up maintains different global environments for different versions of GHC.
Each version of GHC has its own global package database.
Right.
So each installed instance of GHC will have its own global package database. So GHC up is putting GHC somewhere, and the global package database for that instance of GHC will probably live in that same set of directories.
Right.
So when you say GHC package list, what you will get by default is just the global end user. And you won't get, for example, like the Cabal store one, or I mean, this environment file, tells GHC to use it. But if you just ask GHC package list, it'll only give you the global and the user one.
And then apparently Stack maintains its own many package databases. according to
Yeah.
context.
So I think this is a really nice mechanism, and I think we should make better use of it. And I think we should improve our tooling for managing these environment files. And I think there's some cruft from some of the older ways of doing it that could be, complexity that could be removed, which would be quite nice. We're at a hackathon. Anyone want to have a go?
Last question.
Yeah, last question.
How does Nix packages fit into all of this, like compared to Cabal and Stack, for example? And
Well,
does it
we
use
stole all
Cabal
of
the
Nix's
library?
best ideas. Now you don't need to use Nix anymore. I'm only joking. How does it relate? I mean, Nix is its own package manager, but yeah, it can make use of this. But Nix does its own thing, so it doesn't really need to. It's Cabal that really relies on this ability to have multiple instances at the same time, plus environment files. Because whereas Nix has been doing this from before GHC even had these features, so Nix just changes. I think Nix changes the global package database and gives you different ones for different environments or something. I'm not quite sure how it does it, but I don't think it makes use of this mechanism.
Not even of the GHC
Oh,
package
it absolutely
databases?
uses GHC package
Okay,
databases
okay, yeah.
because that's the only way to get GHC to know of the existence of libraries. But I think it doesn't make particular use of these, this kind of funky stuff because it constructs a coherent environment where there's only one version of each library. So it doesn't, it can get away with like the short names. It doesn't need the long names.
Thank you so much, Duncan, for your talk. His slides are up online. I can see that he's gotten through slightly less than half of them.
Something like that.
So there's lots of good information. I encourage you to sit down and read through the rest of them. Potentially, somebody would also like to volunteer to adapt them into a written document. Maybe? We'll see.
All right, thanks very much. Thank you.